In the last video I posted, I showed Doom running on my Zynq-7000 board. And any of you that are familiar with Doom know that the color rendering didn't look right. And if you looked at it, you'd probably figure out pretty quickly that it looked like the reds and the blues were swapped. So I thought, okay, let's get that corrected. I did post that intentionally that way because that's how my system was rendering it. I have been able to resolve that, and it took a little more time than I would have expected it would have. And so I thought I would talk through real quickly what I was running into for an issue, and then how I did a little bit of troubleshooting here, and I'll just show the updated output with, I think, the correct color rendering at this point. So what I might start out with is the problem I was running into was between two things. So first of all, I have Vivado, and in Vivado there is this block of stuff that I'm using. I'm using this RGB to DVI, and that's fed by this stream to video here, and that's fed by this converter, and that converter is pulling information over here from the video DMA. And now in this converter, I can tell it, what am I bringing in and how to rearrange the color bytes. I did a couple of things. I actually was previously using 3 bytes of data. I was bringing 3 bytes of data into this and sending 3 bytes out, and that 3 bytes was going all the way over to this DVI encoder, and then Linux was using those 3 bytes of data. I'm actually finding a little bit better result where I send out 4 bytes of data and I'm just putting in zeros up front. So maybe that would be like an ARGB, and this specific setup of components I have doesn't necessarily support ARGB, but I'm finding that sending this through seems to be helping. I'll go back and try it without that. That may be unnecessary, but it seems like this was helpful to do this. So I'm basically bringing in my 3 color bytes. I'm then changing the order of them around a little bit, and I'm padding it with 8 up front so that I've got a full 32 bits coming out of this. And then that will get over to this RGB to DVI encoder, get that over to my Linux system. Seems like I was doing a little bit of reading about Linux definitely has preference for 32-bit, and this specific output over here is not really giving me much control over color palettes or anything like that, and actually might be a pretty big limitation. That's fine. This is a Digilent component. It's working well for my purpose. I'm just simply now tweaking it a little bit to do this. Now, as I was experimenting with trying to move these bytes around, just changing, which bits or which bytes are in what order, RGB or BGR or something else, what I was seeing on my actual output really was not matching what I was changing here. It was a bit confusing, like why am I making a change here but not seeing that reflected as I actually built my image and up? Well, what I tracked down is kind of interesting. When I go through and I'm done with this, of course, I would generate a bit stream, and then I would do an export, and I'd export the hardware, and I would include the bit stream, and basically then copy this exported XSA file over to my Linux and import that hardware. But what I'm finding is that Linux would not take advantage of or use the latest bit file. So the actual bit stream, even though I told it to include it, it wasn't using the bit stream. It was using the XSA, and I don't know if it is decompressing that and trying to pull the bit file out and then put it somewhere. Ultimately, I believe the correct bit file needs to show up in the Linux folder. So within my Linux project, there's an images in a Linux, and this bit file I was finding was not getting updated through the process that I was using. And I guess that process that I was using, or am still using, if I go over to Linux, I will open a terminal. But what I would do is from Vivado, I would export that wrapper and I would place that into the Linux folder. And then I would come over here and run a command to bring in that hardware. And that command is something like this. And so doing a config, telling it to get hardware description from, and then basically putting to that folder that I have this XSA in. Again, ignore the name. This is just from another project, but this is that Vivado project that's exported, including the bitstream. And at the end of the day, though, as I do this, and then I go through the building, and even if I did come in, there's another option that I was using like this to build the device tree and clean out the state. So I would basically do a clean state, but then I would go on to a normal build, something like a Petalinux build. And as I looked at what it was building and what it was placing into this folder, I was finding that that system.bit was not getting updated. So a little bit of debugging there. I have to figure out why that is not. But for now, what I'm doing is I'm going through the same process. It updates everything in this except for some reason it's missing the bit file. So I'm just manually copying that over into this folder. And then from there, I would then eventually get into where I want to prepare my SD card. And that would be something like this that I would come in here with, is to say, okay, let's package, and then I specify all of this, and it really creates what's necessary to get copied over to my SD card, which is this and this up here. And I've ended up building some little batch files that do a lot of this work, and then from here would automatically copy over the right files onto my SD card. So that process I think is all working fine, but for some reason this system bit wasn't getting updated. So I would make a change, try to go test it, get a little frustrated that I couldn't see any changes, figuring out, am I doing something wrong in Vivado? Is there something else going on that I'm not understanding? But I think it ended up being just simply this bit file wasn't getting moved over properly, even though that bit file should have been part of the XSA, and I would have imagined Petalinux should have dealt with that, but it was not. But all that said, then I was able to get past that. And then if I go to my actual Petalinux, I have the HDMI output here that I'm recording. And that's what's in this window. So if I go in and I just log in, now I can validate my colors. And the simplest thing I'm doing to maybe validate my colors, just to make sure I got my RGB in the correct position, is I'm using this tput. So tput, I can say basically, which is used to set different characteristics of this console output, but I can say set the foreground color to a 1, which should be red. And there you can see it went to red. If I say set it to 2, it should be a green. And if I say set it to a 4, it should be a blue. And I can go back to a white, which is a 7. And so all of that is giving me the correct colors. So I've got my red, green, blue. So I think from a Linux operating system, it's seeing the right data in the right bytes. So then from there, I have my little test program. So I can do an FB test that I wrote, and I can say run test 1 and run it on this dev FB0. And there's my red, green, blue. In a previous video, I had shown that if I go into my project spec and I go my user and I go apps, I had this FB test that I built, and that would be this here. Now, if I pull that up, I have it running over here in Eclipse, or opened in Eclipse. I had made a comment that when I was putting in the code that built those moving color bars, that the positions were backwards on the red and the blue. And I had mentioned that, and I had actually put the FF, for example, here for the red, and I had put the FF here for the blue. And in the video, I had commented that, yeah, it seemed backwards and I'd have to look into that. Well, now as I actually have it properly fixed on the hardware side, I was able to change this back to what I'd expect. So this third byte should be controlling red, this one should be controlling green, this one should be controlling blue. And then if I do show this, you can see that those are now correctly, I am seeing red, green, and blue with the appropriate, what I'd expect to see for the location of the data. So all that goes to just simply say that I think from an OS level and from my custom program that's modifying the actual frame buffer directly, all the color stuff looks good. So then maybe real quick, how did I get Doom on here? I'll go back to my project and my project spec, got a user, and maybe I'll back up. I did put in one additional thing in my layer, and that would be for this libstdl2. That was so that I could build, I believe, some of the Doom stuff, but I did add that to my custom layer. But then I came in and created an app, and I just simply called it Doom. And so that'd be using a syntax that maybe looks like this. And so I would say petalinux-create. I want to create an app. So you say apps. I give it a name of Doom. I tell it to use C as the template, and I enable it right away, which means it goes into the root fs config and turns on that to be built as part of the project. And if I go in, I'll just show you. After you do that, it creates, this structure here, and then under files, we just have a single C file. And it goes in, if I do a petalinux big, and I look at the rootfs, it goes into my user packages, and I now have a Doom option. So I've got my FB test and the flash LED that I had from previous videos, my drivers for my video. So all of that now is just an option in here. But when you set it up with this command, it will enable it in there by default. So then I came in and I erased the files that were placed here to start as part of that create app. And I went out and grabbed from this. So this is github.com Maxim events, whatever it might be here, FB Doom. So check that out, and I just simply grabbed source code out of here and brought that over, placed it into this folder so that I could build this as part of my petalinux build. And then I also downloaded this WAD file, so there's different ones, but basically this is like the game map and game information, I believe. So I went and grabbed one of those and put it into here. And then one level up, I had to modify the BB file. So this is like a bitbake file, which I'm little by little learning a bunch about. But I did come in and say, well, go ahead and include that WAD file as part of my project and all of the files that were in that source code, because it's not just a simple single C file. All of this is needed. And then I go through and I was doing some debugging, so you'll see some echo things in here or things that are commented out. You ignore those. But ultimately, at the end of the day, then this installs it. And for now, for simplicity, I'm just installing it into the user bin folder. But it installs the FP or FB Doom and copies over the WAD file for me, so I don't have to go do that manually later. It's just part of my standard petalinux. Because who doesn't need Doom as part of their standard petalinux image? So then with all of that, as I build my petalinux and I put it on my SD card and I boot up to it, that's essentially what this image over here that I'm capturing is that running on my board right now. So what I'm going to do is just switch my record over to just that. So what you're seeing now is just purely the recorded HDMI output, and I might start by just jumping in. Maybe I'll switch keyboards here and I'll get into my user bin folder. I'll just clear real quick. And so if I do an LS and I do an FBD, there's my FB Doom that's on there. And I can also find that I have this WAD file that's in that folder. Again, probably not the right folder to have that file in. And eventually I will move that over to games as part of my standard petalinux image. But I can now run FB Doom, and if I just run it by saying FB Doom, it's not going to be happy. It's going to say, well, I need a WAD file. Where's that WAD file? So You just do a -iwad and you point to the file, and then there is Doom. And I believe this color output should be reflective of the proper game. So now let's run it through whatever demo, and I can now arrow through this. I can say, well, let's make a new game. If I want, I can go to options and change graphic detail. See, if I press enter, it goes to low. Go to high. I can change my screen size. I can left arrow. You can see I can make that screen size smaller. I can make it bigger and get rid of the little stuff at the bottom. So maybe I'll just leave it right here. I've not tried to get my mouse working with this game yet. I don't know what that will take. Petalinux does detect my mouse, but then of course there's probably some drivers that I would need to make it usable in this if I get to that point. So then I will escape and I can do a new game. So I'll just pick this real quick, and now in I go. And so this is, again, I think the proper color palette that I should be working with as I'm going through this game. Performance, it's obviously an old game. This little Zynq-7000 runs it plenty fine with the HDMI output that I'm using, so no concerns on that. And someone did post a question of how does this compare, to a 486 or something like that. Great question. I'll maybe look into how would I benchmark that. I'm sure there are just basic processor benchmarks, but then it'd be interesting. How in the world would I benchmark my little HDMI configuration that I'm using? But that's all I had for this. So I just real quick wanted to share, in this sub 20 minutes here, what was I running into? What did I have to do to ultimately get it fixed? And it came down to I had to change my byte orders around back in Vivado, but those orders weren't showing up in Petalinux because of not bringing the bit file over correctly. So I've got to figure out what's going on with that. But then from there, I got the proper color output, and then I quickly showed how I brought in FB Doom and am compiling that as an app within my Petalinux setup.